Hello everyone and welcome to another lesson. Today we will talk about tokens on Solana. First I'll go through basics and explain what are tokens and how they work. Then I'll talk about Token 2022 standard and how it expands on the SPL token. And in the second part of the lesson we'll build an example program which uses Token 2022 extensions. There are two main types of digital assets on Solana. The first one is the native currency SOL, which is used to pay for transactions and fees. Then there are tokens, and tokens are digital assets that are created and managed using smart contracts. There are different types of tokens and each type has a different purpose, so here I listed just a few examples. The first one are the stablecoins, which are tokens that are pegged to a fiat currency in order to maintain a stable value. A USDC is an example of a stablecoin. Then there are utility coins, which provide their holders access to some services or features. Decentralized organizations can also issue governance tokens, which give holders ability to vote on protocol proposals or upgrades. And the last example I have here are the notorious NFTs or non-fungible tokens, which can be used to represent ownership of a unique asset. So for example, they could represent ownership of some kind of artwork. Now, let's talk about the three core concepts that are necessary to understand how tokens work on Solana. The first thing are the token programs. Token programs hold all of the logic necessary for interacting with the tokens. Currently there are two token programs. First one is the older SPL token program, which supports basic functionality like transferring, minting or burning tokens. But this was not enough, and a few years ago a new token standard called Token 2022 came out, and this new program expands on the functionality of the original token program. The next important concept are the mint accounts. These accounts basically hold all the information about a certain token. Every token needs to have a mint account because the mint account is what represents the token. Here is the data that each mint account holds. As you can see, there is a mint authority, which is an address of an account that can mint new tokens. It is optional because sometimes we want to make sure that we cannot mint more of a certain token kind. Then there is a total supply of the token and how many decimal places the token has. There is also the is initialized flag to track whether the mint account is initialized. And the last but not least is the freeze authority, which is again an address of an account that can freeze or unfreeze a token, so the tokens cannot be transferred. The last of the three core concepts are the token accounts. Token accounts track how many units of a certain token user holds. A token account can only hold balance of one particular token because each token account is tied to some mint account. So user can have several different token accounts for one token, but they cannot store more tokens in a single token account. They need a different one for each token type. Here you can see what data each token account contains. The account has to be tied to some mint as well as a user. Then there is a number of tokens that the account holds. Token accounts can also have a delegate, which has a delegated number of tokens that they can spend on behalf of the owner of the token account. Then there is a state field which tracks whether the account is initialized, uninitialized, or frozen. The isNative field is pretty interesting because it tracks whether the account holds wrapped SOL. So sometimes we wanna wrap SOL into a token because it allows for easier integration with protocols that expect token accounts. The reason why the type is U64 is that if the token is native, so it is a wrapped sol, then the value will represent the number of LAN ports the account needs to stay rent exempt. The last field is the close authority, which is pretty self-explanatory. It is the address of the account that is authorized to close the token account. Associated token account is a regular token account, but it has an address that can be derived deterministically. The address is derived from the mint, from the address of the mint and the address of the wallet. Because of this, each wallet can have only one associated token account per mint. Good thing about associated token accounts is that the sender can create the account for the recipient. So for example, if you were running an airdrop campaign or you wanted to send your friends some tokens, but you only knew their wallet address and not the token account address, you could transfer the tokens to their associated token account anyway. So this is how the address is derived, and these are the seeds. As you can see, there is address of the token account owner wallet. Then there is the mint and the token program ID. Alright, this was a lot of information, and I know that it might be a bit confusing for those of you who are seeing this for the first time, so we prepared a diagram to show you relationships between all these components. So let's go over it one more time. Token programs store all of the logic used to interact with the tokens. Token programs also own mint and token accounts. Each token account is tied to one mint account, which stores all information about the token. System program owns system account, which is a regular wallet, and each token account is tied to a wallet. Wallet needs to have a different token account for every token and can have exactly one associated account per token with deterministically derived address. Wallet can be assigned as the mint or freeze authority of a mint account. Here's the whole diagram, and I hope that this explanation cleared things up and did not make you even more confused. You should now have a pretty good understanding of how all these components relate to one another. Initially, there was only the SPL token program, but this original token program only provided limited functionality, so a bit later Token 2022 standard came out, which is a backwards compatible but upgraded version, and it provides all of the functionality offered by the original token program, but it builds on top of it and supports modular extensions for advanced features. There are two kinds of extensions: the mint and account extensions. Here's the list of the mint extensions. We will not go through all of them because the list is pretty big, but in the second part of the lesson we will build an example program which will use the transfer fees extensions to show you how you can use them in your programs. Also keep in mind that some of these extensions are not compatible with each other. For example, it would not make sense to have a token that uses transfer fees, but the tokens are non-transferable. And these are the account extensions. We will also put a link to the documentation in the video description so that those of you who are interested can read about these extensions in more detail. Now let's build an example program which will be able to create new token, mint and transfer tokens, and since we'll be using the transfer fees extension, we will also need an instruction that will allow token creators to withdraw tokens they collected on fees. I will be using our School of Solana Docker image, so if you want to follow along with the lesson, you can. The link to the Docker image as well as to the completed project will be down in the description. I created a new Anchor project and let's build the example program. So first I will create a new folder for our instructions. So with this instruction, we'll initialize our token. So we will definitely need some signer who will own the mint. Then we'll also need the mint itself. Let's make it signer. We'll also need the token program. And let's also add the system program. We will need it because we'll be creating an account. Now we will set up account constraints. So for the signer, we will only need the mute constraint. As for the mint account, usually when you're creating a mint account, you wanna initialize it using the mint constraints like this, right? So you can set authority, then you can set decimals and so on. And what you can also do with the extensions is that for some of the extensions, you can set them also using the constraints. But while I was trying to do this example of camera, I noticed that the transfer fee extension for some reason does not work like this, so we'll have to initialize the mint account manually. So for now we'll use just the mute constraint. So when we want to create a mint account with token 2022 extensions, first we need to create the mint account itself. So let's we'll do this through a CPI. So first we need the CPI context. No, this will be create account context, CPI context, new, and first we'll need programs. So maybe let's just add the accounts here. Let system program equal to context.accounts.system program. Let's add a reference and system program.toAccountInfo. Then we also need accounts. Let's do create account. And what accounts do we need from and to? From creator mint. So we'll be creating to account info to mint.toAccountInfo. Good. So we have the context. Let's create the instruction. Create account. Is this? No, this is not the right one. Create account. This one, the CPI. So we include the context. Then we need to specify the number of LAMP ports and space. Alright, so let's calculate space. Let space is equal to, and first we need to specify the extension type. Try calculate account length, extension types, extension type, and we'll be using transfer fee config. This returns result. Okay, nice. So we have the space. We also need the number of LAN ports. Minimum balance and space. LAN port space and owner. And owner will be the token program. If you remember the diagram, token program owns the mint account. Token program dot key. What's wrong? Space SU64 and key. This should be a reference. Nice. What's wrong here? Type annotations needed. Oh, so we also need to specify this. And with the type annotation, we also need to include the type annotation. And this should work, right? Okay. So now that we created the account, we need to initialize the extension. We do that using another CPI. So first let's create context. Context and CPI context new. First we need the program, token, program to account info. Then we need account, so transfer fee initialize. And what accounts do we need? We need token program ID and mint ID. Token program ID will be token program to account info and mint to account info. Alright, that's it. Now let's create the instruction, transfer fee initialize. And first we need context and we need transfer fee config authority, but in this case we do not need to set that authority because we will not have any additional instructions that would allow us to change the fee. So we can leave this as none. We definitely want to set the withdraw authority. That will be the creator dot key. Okay, context, we already prepared context, transfer fee init. And the transfer fee basis points is basically like the percentage of the transfer that will be withheld on every transfer, the percentage of tokens that will be withheld on every transfer, and the maximum fee is, well, exactly what it says. Fee basis points U16 max fee U64. Let's also update it here. What am I missing? Not in scope. Is it? No. Creator fee. This has to be sum. And right here we need a reference, and that should be it. Yes. Great. So we initialize the extension, and now we need to initialize the mint account we created earlier. So let's create another CPI context. And we only need the mint account to account info. Initialize mint context. We'll hardcode in 9 decimals. The mint authority will be our creator. We don't need freeze authority. We need this and this. Fine. So I think this should be it for the initialize. So one more time. First we'll calculate the space and LAN ports we need. Then we create the mint account. We initialize the transfer fee extension. And last but not least, we initialize the mint account itself. Let's create second instruction. We will need the mint instruction. This time we'll only need the amount as a parameter. Okay, and let's do the accounts. So we need the creator because he'll be minting the tokens. Then we need the mint, and this time let's use interface space account, set it to mint. And for the constraints, we want to verify that the creator is the mint authority. And that mint token program is equal to token program. We also need the recipient for who we will mint the tokens. Up recipient, and we can use unchecked account. Now we'll create associated token account for the recipient. And let's create it using the constraints. So we'll use init if needed constraint, because if we're minting more times to someone, we don't want to initialize a new account every time, or rather we can't. But we need to add this feature right here. Init if needed. Oh, right, okay, it works. So we must provide pair. Pair will be the creator. Then we need to specify mint. We need to specify owner of the account. Authority, which will be recipient. And we also need to specify the program. What's wrong? Alright, we did not add the associated token program. So we have the recipient, associated token account, we have the token program, system program, and associated token program. So now let's update the instruction. First, let's check whether amount is something other than 0, and we'll panic if it's 0. Invalid amount. Now let's prepare the context for our mint. So mint context. We'll use token program. And right here we need mint to. And we will need mint to and authority. So authority will be creator. To will be, this will be mint account. And to will be recipient to account info. And let's also add recipient here, or let's do it like this. We need the associated token account. Account. Authority mint recipient. Okay, let's update this. Mint 2. Is this the correct one? Yes, it is. And we need the context and amount. We can get rid of this. Anchor SPL token mint. Guess I implemented incorrect. Mint. Mint. And let's also get rid of these unused imports. Okay. So we check whether the amount is 0. Then we prepare the context and mint to the recipient's token account. All right. Let's create the transfer instruction. Transfer. And we'll keep the amount. Transfer. Fine, so let's update the account. So this time we will not have a creator, but we will have a sender. Mint can be an unchecked account this time. Mint can be unchecked because we are not minting anything, we just needed to basically specify which token we are transferring. Then we will most definitely need a recipient, and I think I forgot to make the recipient mutable, right? So let's copy this and put it right here. And also let's make the recipient mutable here as well. Now, if we need to initialize, we can keep this because somebody who we are sending tokens to might not have the token account yet. But this time sender will be the one who pays for the account creation. Oh, we also need the associated token account of the sender. But he needs to have the account already created. Authority will be sender. And I believe we have all of the accounts. So now let's update the transfer instruction. Transfer. This time we'll need to use transfer checked. We cannot use regular transfer if we have a token which uses the transfer with fee extension. Transfer checked. Right. And we need the context, amount, and decimals. So transfer context, amount, and decimals will be 9. Transfer checked. We need from authority mint, sender and recipient. Sender. So now we need the last function, which is the withdraw function. Okay, so we will definitely need a creator, because only he is allowed to withdraw withheld tokens from the recipient token accounts. Then we definitely need mint. We have the recipient. Let's rename this. Let's use from, because we'll be withdrawing tokens from this account. Account. From. This time we do not need init if needed, because the account needs to be initialized in order to withdraw the tokens. Which means that we should not need the system program. Oh, no, we do need the system program, because we also need to add associated token account of the creator. And at this point he's still, or I mean the creator might not have the token account created. Creator associated token account. And what am I missing? Oh, right. Creator. So we have the mint, we have the account from which we'll withdraw tokens, we have the creator token account, we have all the programs we need. So let's finish the final instruction. Withdraw context, and we need withdraw withheld tokens from accounts, and the accounts are token program ID, mint, destination, and authority. So authority is the creator. Mint is also correct. destination will be creator associated token account. And we also need the token program ID, which will be token program to account info. Now the instruction itself, withdraw withheld tokens. Is it this one? Withdraw context. We don't need them all, we just need sources, which are the accounts from which we'll be withdrawing. We only need the one we specified in the context. You can withdraw from more accounts at the same time, but this time we'll only do the one we have specified in the context. Off camera, I prepared a few simple tests to verify the implementation. First, I basically just prepare a few accounts and airdrop some SOL. Right here down I have a few utility functions which are for logging balances of token accounts, airdropping SOL, and basically easier access to account addresses and account data. So in the first test, I just initialize a mint and then verify whether the account was initialized correctly. In the second test, I mint some tokens to the recipient number 1 and verify whether he received the tokens. Then in the third test, I transfer some tokens from recipient number 1 to recipient number 2 and verify whether correct amount of tokens is withheld on the recipient number 2's token account. And last but not least, I try to withdraw withheld tokens to the creator's token account. So let's try to run this. Alright, the program needs to build, so I'll be right back. The build failed. I did not add this feature to the ideal build. So let's do that. And that should do the trick. Oh, right, we also do not have the key pair created in the Docker image yet. So let's do Solana keygen new. Quickly generate a key pair and try again. What is the issue this time? Cannot find module SPL token. Let's install this module. Let's try again. And finally. So first we initialize the mint with transfer fee extension. Then we mint tokens to the recipient. And when we transfer tokens, we also log the balances. We transfer half of the balance of the recipient number 1 to the recipient number 2. And as we can see, 2,500 tokens were withheld because, let's check the, these were the basis points, so 500. So 5% of the transferred amount was withheld. Then in the fourth instruction, we withdrew the withheld tokens. and creator received them, so it works correctly. That is it for today. As always, if you have any questions regarding the topics discussed in today's lesson, feel free to reach out to us on Discord and we'll do our best to answer all of the questions. Hope this helped and see you next time.